Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 21 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2145. Count the hidden sequences. So let's read the problem statement first. You are given a zero indexed array of n integers differences which describes the differences between each pair of consecutive integers of a hidden sequence of length n plus 1. Okay, so what we have given? We have given a zero indexed array of n integers differences. Okay, and this describes the difference between the each pair of consecutive integers of a hidden sequence of length n plus 1. Okay, so if differences are given to like this a b c, okay, so let's say this is my difference array, right? So the hidden array that I'm going to form, all right, so that hidden array uh, is consisting of n plus 1 elements. Okay, so let's say here it is x1, x2, okay, x3 and x4. Okay, so this is given to us, okay, difference. And how this a value is coming up? A value is nothing but x2 minus x1, b value is nothing but x3 minus x2, c value is nothing but x4 minus x3, right? More formally, call the hidden sequence hidden, then we have that differences of I is equal to hidden of I plus 1 minus hidden of I. Okay, that's what I have explained here, right? You are further given two integers lower and upper that describe the inclusion range of values lower upper that the hidden sequence can contain. Okay, so for example, let's suppose this is the differences array given to us 1 minus 3 and 4. Okay, and this is lower and upper value, right? The hidden sequence is a sequence of length 4. Okay, since this is having length 3, so the hidden sequence is going to be of length 4 whose elements are in between 1 to 6, okay, inclusive. So we can use 1 and we can also use 6, okay, inclusive, right? So here one more thing, 1 to 6 we are using, okay, 1 2 3 4 5 and 6. Okay, these are the number of elements that we are using. Okay, so this is my lower and this is my upper. Okay, so if I ask you guys that tell me how many elements are in this range, so you are going to say that six elements are there, right? 1 2 3 4 5 6. Okay, and there is also one way to write this. Okay, so I can also write it like this: upper minus lower plus 1. Okay, so I am going to use this formula in my code: upper minus lower plus 1. Okay, so upper is 6 minus lower is 1 plus 1, so I will get 6. Okay, so this is nothing but the range. Okay, so total 6 elements are in this range, lower to upper, right? So this is formula, so that's why we are using this plus 1. Okay, so I am highlighting this part. Okay, we are going to use this plus 1, okay, in some part of code. Okay, so that's why. All right, so now see here, uh okay, so this is one valid hidden sequence. Okay, 3 4 1 5. Okay, so here if you see 4 minus 3 is 1. Okay, 1 minus 4 is minus 3. Okay, 5 minus 1 is 4. It's okay. Then here 5 minus 4 1. Okay, 2 minus 5 minus 3. Okay, and 4 minus here see 6 minus 2 is 4, and this is also okay. Okay, so our possible hidden sequences, but this 5 6 3 7 is not possible since it contains an element greater than 6. Okay, 7 is here, so this is not possible, right? And same way this is also not possible since the differences are not correct. Okay, so we have to return the number of possible hidden sequences there are. If there are no possible sequences, then we have to return 0. Okay, and I hope that you guys are clear with the problem statement, and this is important problem. Okay, Meta asked this question. Okay, and I have seen a lot of companies asking the same question during interview rounds. Okay, this is important, right? Market is important. Okay, so now here this is done. Okay, we are clear with the example. Okay, so this is the same example, right? 1 minus 3 4. Okay, so possible hidden sequences are this. Okay, so here one thing that we can do. Okay, so differences arrays, if you see 1 minus 3 and 4. Okay, and we have to form the hidden sequence. Okay, so we already know the length is going to be 4. Okay, so here I'm creating the 4 dashes. Okay, so here we will also know that lower is starting from 1 and until 6. Okay, so here if I fix 1 here, okay, if I fix 1 here because it's starting from 1, right? If I fix here, then if I add this 1, okay, here 1 plus 1, I will get 2. Okay, 2 plus minus 3, I will get minus 1. Minus 1 plus 4, I will get 3. Okay, so I'm just going to add this, and here I'm writing the output. Okay, minus 1 plus 4, I'm writing here output. Okay, so if you see here, if I just know the first element, I can form this complete sequence, right? So this is valid sequence or not. Okay, let's check that now. So here if I know that this starting value, okay, let's say x, if I'm taking it as 1, so then I will come to know all other elements if I just add the differences. Okay, so now here see, if I do 2 minus 1, it is 1, right? If I do minus 1 minus 2, I will get minus 3. This is also right. 3 minus minus 1, if I do, I will get 4. This is also right. So with this array, we can get this sequence. But there is still one problem. What is the problem? See this element. This element is lower, okay, is less than this lower value. Okay, so this should not be the case. Okay, so here where is that mentioned? Yeah, you are given two integers, lower and upper, describe the inclusive range of the values. Okay, so this value minus 1 is smaller than lower. Okay, so this is not valid. Okay, but from here you come to know that if you know just first value, yeah, you can form the this complete hidden sequence, right? Right, so here let's suppose this time you start it from 3. Okay, so if you start this from 3, 3 plus 1, 4, 4 minus 3, 4 plus minus 3, you are going to get 1, 1 plus 4, you are going to get 5. Okay, so see, this is valid. Okay, all the elements are in range 1 to 6, okay, inclusive, right? This is valid. Now 4 minus 3, 1, 1 minus 4, minus 3, 5 minus 1, 4. Okay, so this is one pass possible. Okay, so this is done. Okay, so here you may think of doing this like, first you are going to consider this 1 as starting, then you will form everything, and then you also check side by side if any element is lesser than lower or greater than upper, then you will just break. Okay, otherwise if we are able to form, then you have to increment the count. Okay, so you can think like that, right? 1 if you start from 2, then 3, then 4, okay, then 5. Okay, this is what I think most of you guys are thinking right now. Okay, we are going to start by taking x as 1 first, then 2, then 3, then 4, then 5, 6. Okay, then while forming this complete, we will check if any element is out of range. Okay, then we will break that. Okay, then we'll start from next. Okay, if all elements are in range, we are going to increment the count plus 1. uh, okay, like here you are going to increment the count plus 1, here you are going to increment the count plus 1, and here you will break that, here you will break that. Okay, so this is what you guys are thinking, right, as per now? Okay, but here there is one more problem. Okay, see the constant size. So first you are going to run one loop from lower to upper, then inside this, okay, inside this you are treating first element as, let's say, x, then here inside this you are going to again check all the elements. Okay, for going to form all the elements, and you also going to check if they are in range or not. Okay, if they are not in range, you are just going to return false. If they are in range, you are going to increment the count. Okay, so but here you are going to use two loops. Okay, so one is from lower to upper. Okay, so here lower to upper value see 10 to the power 5. Okay, very big, 10 to the power 5. Okay, and inside this also you are going to iterate over all the differences array, right? Here you have to just plus. Okay, I do the addition, then you are going to get next element, then you are going to do the addition with the next difference element, then you will get this, then you have to add this with the next difference element. Okay, so you are iterating over all the n elements. Okay, so this n value is also 10 to the power 5. Okay, so definitely you will get time limit exceed error in this case. Okay, so this is not a best approach. Okay, this is brute force. Okay, so first let me show you the brute force code. Okay, so see this code, this is brute force code. Okay, so I'm calculating the length of nums. This differences array count is 0 initially, then lower to upper I am taking. Okay, so now I'm taking the current element as first I value. Okay, I is starting from lower to upper. Okay, then I am taking this boolean array, boolean value valid. Okay, I'm setting it to true. Okay, so right now it is true. Then I am going to iterate over all the elements in my differences array. Okay, so I'm running loop j0 and j plus plus, and new number is going to be current number plus differences of j. Okay, and next, for the next time, my curry is going to be new num. Okay, so here see this 1 1 plus 1 2. Okay, so next time this is the current number now, so that is why I'm taking this current as new number, and then I'm checking if this is valid range. Okay, if it's not a valid range, so I'm setting it to false and I'm breaking it. So here if valid still remains true, okay, then I'm incrementing the count. So here returning out. Okay, so code is very simple, this brute force, right? With this code 75 test cases got passed only out of 86. Okay, and we are getting what? Time limit exceed error because of time complexity of n square. So now we don't want this time limit exceed error. Okay, so now how we are going to optimize our code? Okay, so now let's see that. Okay, so this is done. Now let's take the same example. Differences 1 minus 3, 1 minus 3 and 4. Okay, this is my differences array, and we know that our lower value is 1 and upper value is 6. Okay, all right. So now here if I pick just this is one valid scenario, right? 3 4 1 5. Let me pick this 3 4 1 5. 3 4 1 and 5. This is valid. Okay, okay. So now before proceeding further, okay, here if let's suppose this is a0 a1 and a2, okay, until an. Okay, so let's suppose this is a valid array. Okay, this is one valid array, right? So here in this array, if at all the places I add a constant value, let's say k. Okay, a1 plus k, a2 plus k, okay, and a of n plus k. Okay, then also this is going to be valid only, right? Why this is going to valid only? So see here, here 3 4 minus 3 difference is 1, 1 minus 4 difference is minus 3, 5 minus 1 difference is 4. This is valid. Okay, now in if I add plus 1 in all these, okay, so here I'm adding constant k. Okay, or you can subtract. Okay, you can do anything. Okay, but you are going to do that in constant. Okay, here k, you can add k value as plus 1 minus 1, it's your choice. Okay, so here I'm adding plus 1 everywhere. Let's say plus 1 plus 1 plus 1 I'm adding everywhere. So the new array that I'm going to get if I add plus 1, okay, the constant value k, okay, if I'm adding everywhere, so I will get here 4, I will get here 5, I will get here 2, and I will get here 6. Okay, so here see this is also valid, right? 5 minus 4 is 1, 2 minus 5 is 3, minus 3, and 6 minus 2 is 4. Okay, so this is also valid. Okay, so both are valid only, right? And make sure that the this range should be valid. Okay, L to upper. Okay, so this is valid, right? So from here what I can derive. Okay, so let's suppose let's suppose here from here you can say that let's suppose the minimum element. Okay, whatever the minimum element in this the new sequence you are going to form. Okay, in those minimum elements, okay, so you can say prefix min. Okay, prefix or min prefix you can say, or prefix min. Okay, let's say prefix min. Okay, so in the prefix min, okay, whatever the element you have, okay, whatever the minimum element, okay, in that element if you add any value of k, okay, so if you add any value of k, okay, so value should be always be, okay, you have to make sure it should always be greater than equal to lower. Okay, so here in this one, let's suppose if I add a minus 1, okay, if I add minus 1 it is going to become 0, so 0 is not valid, right? So whatever the value in my prefix min, okay, whatever the minimum prefix value, okay, I'm going to add any constant value k, so whatever the output that I'm going to get, it should be greater than equal to lower for valid scenario, right? Same way, let's suppose there is one max value, let's say here 6, okay, whatever the max value, so here I can write prefix max, okay, prefix max. Okay, in this value, whatever the k value that I'm going to add, it should always be less than equal to upper range. Okay, so in this 6, if I add, let's suppose 1, I will get 7, but 7 is not in valid. Okay, so here whatever value I'm going to add in this case, it should be less than equal to lower, right? This is clear here, right? And here I can also write it like this. Okay, so I am specifying the boundary, right? So my boundary is like this, prefix min plus k value. Okay, so okay, prefix, this is going to be k. Okay, and here prefix max plus k. Okay, prefix max plus k. All right, so this is the value, right? Prefix max plus k. So this is nothing but boundary conditions, right? Whatever the value of k I'm going to add, so this is going to be my lower. Okay, and this is going to be my upper. Okay, until here, right? And both are inclusive, right? So both are inclusive. Okay, both are inclusive, right? So here also we can do one more thing now. We have to specify the range. Okay, so can I write here, just derive the k value. Okay, k value. Okay, so k value I can write whatever the k value that I'm going to add. Okay, so I have to specify the range. Okay, so k value should be greater than equal to lower minus prefix main. Okay, prefix main. All right, okay, so now here I can write this like this as well. K should be greater than equal to lower minus prefix main. Okay, so here let's say I am writing main only. Okay, prefix main, or you can write prefix main or main. Okay, no issues. And same way here I can write k value. Okay, so I'm specifying the range. K value should be less than equal to, okay, whatever the k value that I'm going to add. Okay, so it should be less than equal to upper minus, and here max. Okay, I can write it like this. All right, okay, clear. Now if I want to specify the range, so this is going to be the range now. Here lower minus min, and here upper uh, upper minus max. Okay, upper minus max. Okay, so now this is range now. This is range and inclusive range. Okay, so here I can let's suppose this is a to b. This is range from a to b. Okay, so let's suppose this is a value, this is b value. So I told you now, if when values are inclusive, then we have to write the elements in the range as b minus a plus 1. Okay, where I have specified, it as some here now. The see this upper minus lower plus 1. Okay, so here plus 1 we are doing that, right? So we are getting 6. Okay, so this is the formula that I'm using. Okay, so here I can write it like this. Okay, I can write it like this, upper minus max. Okay, and here I'm writing this a as lower minus min. Okay, and here plus 1. Okay, and here I can also write it like this, upper minus lower. Okay, and here I can write it like this as well, minus, I'm just rearranging, right, max, and here minus min plus 1. Okay, so this is going to be the give me the range value. Okay, how many elements in the range. Okay, so range of what, it is going to give me the range of the x value. Okay, so starting value that I can use. Okay, whatever the starting value I can use. Okay, so here we can use 3 and 4, right? Starting value of x that we can use, right? So this is what it is going to give. Okay, so here this is done. Okay, and here make sure now that this value should not be less than equal to 0. Okay, so if this value is less than equal to 0, then just return 0. Okay, whatever the value is. Okay, it should be greater than 0. If it is less than equal to 0, just return 0, right? We have to make sure. Okay, we have to just calculate the value, right? So this is given problem statement as well. Return the number of possible hidden sequences there are. If there are no possible sequences, okay, we are going to get some negative value there. Okay, then we have to return 0 only, right? So this is given to us, right? So this is the formula that I'm going to use now. Okay, so here in this case you see 1. Now let's do the dry run on this example. 1 minus 3 4, 1 minus 3 and 4. Okay, so initially what you need to do, take the min value. Okay, here min value 0, max value equal to 0, and the take the prefix as 0. Okay, prefix as 0. Okay, so now I have to fill the values. Okay, so and we already know the upper value is 6, lower value is 1. This we already know. Okay, so now first I'm going to iterate over all these differences array. Okay, I'm going to solve this problem in of and time complexity now. So first this element. Okay, so initially my prefix 0. Okay, I'm taking 0. Okay, initially let's say x value. Okay, so starting value let's say 0 only. Okay, so in this 0, if I add 1, so I will get prefix as 1. Okay, now side by side update the min and max. Okay, so min and max, what is going to be my min and max? Okay, so min you can write it as math.min of the min value. Okay, current min value, and here prefix value. Okay, and here max is nothing but math.max of, here you have to write max and prefix value. Okay, so here you are going to get 0 only, and here you are going to get 1 only. Okay, so this is the range. Okay, right now, and then after that here here if you move, okay, to the next element, then your prefix, it is going to update as a 1 plus minus 3, you will get minus 2. Okay, prefix as minus 2 you will get, and here you are going to get min as math.min, and here min p. Okay, so min value you are going to get minus 2, and the max value you are going to get here, it is going to remain 1 only. Okay, then you are going to reach here minus 2 plus 4, you are going to get p is equal to 2. Okay, then you have to min is going to become as minus 2, and max is going to become as 2 only, right? Here you will get 2. Okay, so we are iterate over all the elements in of and time complexity, and this is the final min and max value. Okay, so now here what does this mean? Okay, this min and max value. Okay, so here just apply this formula. Upper is 6, minus lower is 1, your max is 2, your min is minus 2, and here plus 1, you are going to get 5 minus 4 plus 1, you are going to get 1 plus 1, that is 2 as the output. Okay, so this is valid. Okay, so here if you see here, here lower value is 1 minus minus uh, minus 2. Okay, and here upper is 1, upper is your upper value. Here what is the upper value? Upper value is 6. Okay, 6 minus max value is 2. Okay, so here you are going to get what? See here, 1 minus minus 2 3, and here 6 minus 2 4. Okay, so that simply means this is the x value. Okay, so you are starting once from this 3, then you are starting from 4. Okay, then you have to find everything. Okay, so these are the valids, right? So here if you see in your code, so once you are starting from this 3, then this is 4. Okay, so what we are calculating here, we are just calculating the range of this x. Okay, and I have already derived the formula, okay, with which we are going to get our output. Okay, so this is how you have to calculate the your output. Okay, so here this is nothing but the range. Okay, so this is the how we calculate the range. Okay, so I have already derived the formula like b minus a plus 1. Okay, 3 4. Okay, and 3 4 you have to write now 4 minus 3 plus 1. Okay, 4 minus 3 is 1 plus 1, so 2. Okay, that's it. So this is the formula. Okay, and I rearranged it like this, and I am writing it like this to get the same answer. Okay, so that's it. Okay, so now let's write the code. Okay, so code is going to be very small, and we are now able to solve this problem in of and time complexity, right? So this is very important. Okay, again I'm saying this, they may ask you in interviews, right, for the optimal approach. So here first long min is equal to 0. In the start let's take 0 only, max you have to take 0 only, right, in the start, and the prefix you have to take it as 0 only, right, and then you have to iterate over all the elements in difference array one by one. Okay, int diff in differences. Okay, and here inside this prefix you have to update as prefix plus diff. Okay, and here min as, okay, min value you have to get as math.min. Okay, so this is the mean value that at most you are going to get, okay, using the this difference array. Okay, so here mean and here prefix. Okay, and what is the max value that you are going to get after doing all these additions in the prefix? So max, you are going to get math dot max here. Okay, and here you have to write max, and here you have to write prefix. Okay, so now this is going to help us in specifying the range. Okay, so how min we go, how max we go. Okay, so we need this min and max. Okay, so that's what I was saying here, right? Here I gave you example that like in this, if I add the k with k element, okay, how many k elements I can add this so that it doesn't go out of bound, how many k elements I have to add this. Okay, so that is why prefix min, prefix max we need, right? So this is done, and here the range, okay, long uh, range. Okay, and you already know the formula for this one as well. Upper minus lower minus max minus min, and here plus 1. Okay, and here you have to just return int. Okay, and we no need to return my negative value. Okay, if there are no such cases, then just return 0. Okay, math.max, and here 0, whatever max 0 or this range value, right? That's it. Okay, now let's run the code and see if there are any code issues. We'll try to fix that. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.